Hello and Assalamualaikum. My name is Nasuha and my mentor number is AE180014. And today I'll be presenting about my final year project 1, which is Interpretation and Translation of Malaysian Sign Language for Hearing Impaired Individuals using MATLAB. Okay, so here is a couple of information about me. My full name is Nasuha binti Bacho. My metric number is AE180014. And I am a student currently studying in Electronic Engineering Mechatronic at UTHM. So here is the project architecture. So basically my project is to build a system at MATLAB that can detect sign language using hand gestures. Okay, so for the project architecture, this is the general architecture. First we will have the input image, and then later on the image will undergo through pre-processing methods, which will then later on extract the features from the gestures. Then it will undergo system training and system testing. From the system training, it will then update the system database, which will then be retrieved into system testing. Then later, the system can detect the gestures. Okay, so now we will talk about the dataset and pre-processing. Okay, so for the dataset, for my FYP1, it will only consist of vowel character A, E, I, O, U, and also a default background, which is a plain light colored background. So this is the A, E, I, O, U in MSL, which is Malaysian Sign Language. Okay, things to note. Each character will have 150 images, 75 from the right hand and 75 from the left hand. This is because since sign language does not exactly specify which hand that should be used, instead they only say that the user will have to use their dominant hand. So that's why I prepared equal values from each hand. Okay, so for the left hand, it will merely be a flipped version of the right hand image, meaning left hand image will merely be 180 degrees of the right hand image. Okay, so this is the pre-processing steps that the image will undergo, which is only resizing. Okay, so the original image is actually 2340 pixels by 4160 pixels, and then later on, after it has undergone the resizing, it will turn into 227 pixels by 227 pixels. This is because we want to match the picture into the ones that I use in AlexNet, which is in this frame. Okay, so now I will show a video demonstrating the system at MATLAB. Hello, my name is Nasuha, and today I'll be presenting about my final year project demonstrations. So as you can see here, this is the boundary box for the processing area, right? So in order to make it easy for me, I will use my left hand. Okay, wait. Okay, so we have we're going to do A. So A is this, if I'm not mistaken. Oh my, yeah. So we're going to try. Okay, so now we can get, this is the A, right? So it can detect A. So now we will do E. If I'm not mistaken, it's like this. Okay, go back a little bit. Okay. Oh, there you go. Okay, so this is the E. And now we will do the oh, I think it's like this. Okay, here is the O. We can see that we managed to detect it. Okay, so now we're going to do the I. So, where are you going? Okay, here is the I. Okay, trying to get into the boundary box. Right. Oh, okay, here it managed to detect the I. So now we're going to do the last one, which is U. I don't know why, but the system managed to mistaken U for the default image, which is the blank background. Okay, so U is this, if I'm not mistaken, is a peace sign. Going to review. Okay. So now, yeah, we can get new. Okay, so that's it for the demonstration video. Thank you. Okay, so observation and discussion. Okay, so what we can observe from the demonstration video. First, the boundary blocks are placed in an awkward position, making it hard to capture the input image. Second, for the U or O dataset, the system keeps on mistaking them for the default dataset, which is the plain background. And third, since the input is detected in a video frame, it is quite hard to detect the accuracy of the system because we can see that the output keeps on changing, right? So we can't detect whether it's accurate or not. We can't exactly put value, a percentage of accuracy to it. Okay, so discussion. Okay, so for the first observation, perhaps it can be solved by the boundary box size can actually be set up at the MATLAB coding. So meaning we can change the boundary box to be much more bigger than the ones shown in the demonstration video. Okay, so next for this problem, perhaps we need to add more pre-processing steps, which is like from RGB to binary, or maybe edge detection method. Because from the previous research, the pre-processing steps that they took always often contain those two steps. Perhaps we can do that. So for the third one, maybe we need to improve the overall system so that the system can easily detect the gesture. Okay, so conclusion. Okay, so the system are able to translate the gesture detected into its respective datasets. Okay. However, a couple of changes should be done as to further improve the system, such as perhaps adding more datasets, perhaps 150 images is not simply enough, and then later on add more pre-processing steps such as binarization or edge detection. Okay, so that is all from me. Thank you.